Good morning, class, and welcome to this lesson on Kinematics 6 Free Fall, Part 1. Today we'll be able to define free fall acceleration. So we're just going to define this and give a few examples as to what it really means. So free fall. Free fall. Free fall is an idealized motion where an object accelerates due to, where an object constantly accelerates, constantly accelerates due to gravity in a frictionless environment. Okay, idealized motion where an object constantly accelerates due to gravity in a frictionless environment. So, basically what this is trying to say is if an object falls relatively close to Earth, okay, it will accelerate constantly. It'll accelerate constantly. So if it is relatively close to the Earth, not way out here, okay? But if it is relatively close to the surface of the Earth, it's going to accelerate at a constant rate. And we're going to assume it's a frictionless environment. So frictionless means like no air resistance. No air resistance. So what does this really mean? Gravity is a constant number. Gravity is a constant number if we are close to the Earth. So let's take a common situation. We have a rock and we have a piece of paper. Now, if there was air, if there was friction, and we let both of these two things go, we know the rock would fall faster than the piece of paper, um, because the piece of paper is going to meet resistance due to air. However, if we were able to take this tube and suck out all the air so there is no air inside, it is a frictionless environment, and we drop both the rock and the piece of paper, they would accelerate. They would drop at the same exact rate. They would accelerate at the same speed and they would hit the ground. They would hit the ground here at the same time. I highly suggest if you want to see this, there's a whole bunch of YouTube videos. Just type in free fall demonstration, and you can watch many different demonstrations of this happen. So if we drop two different objects in a frictionless environment, they will free fall at the same exact rate. So same thing, any two objects, all objects accelerate at the same rate in free fall. Okay? So if it's a car, if it's a human, if it's a bowling ball, if it's a feather, if it's a piece of dirt, it doesn't matter what it is, all objects will accelerate at the same exact rate in free fall. And that rate is 9.8 meters per second squared. Notice this is units of acceleration. So every single second, it is going to the object will fall another it will fall another 9.8 meters per second. Okay, so it is an acceleration. Okay, and very often, just to let you know, as a test-taking classroom type thing, very often on tests, they just say use 10 meters per second squared to make the math a little bit easier, because multiplying or dividing by 10 is a very easy thing to do. So this is for like test-taking purposes, okay? But get used to using 9.8 for most of the time, and then you can use 10 if it tells you to do so, okay? So a couple more things. Just a couple things about free fall acceleration, okay? We have our equations. For example, we have this equation right here, x equals v naught t plus 1/2 at squared. It is very, very common. You see the a right here is acceleration. Well, if we're in free fall, if we are in free fall, we will change this to 1/2 g t squared. G, little g, being the acceleration due to gravity. Okay, so that's what this 9.8 is little g, okay? So sometimes you might see the letter g in an equation because what it's saying is it's in free fall, okay? Um, so very, very often, um, an object will start off from rest, and so we can cancel out this term right here. And so this equation is very, very 1/2 gt squared is a very popular equation. You're going to use it. You're going to use it a lot because physicists like free fall questions. Okay, so if an object starts out from rest and it falls continuously down, um, then it's in free fall. Notice here in this picture, the person who is solving this problem, they said that positive is up and negative is down. Therefore, if I was going to use this equation right here to figure out how far this thing has fallen, I would write x equals 1/2 negative 9.8 meters per second squared. And then in this situation right here, it is 3 seconds squared. And the reason I'm calling this negative is because I'm calling negative down. Okay, so you have to be very wary of that. If I call down negative, I have to put a negative sign for my acceleration. Okay, so if you want to, you can very easily change this and make this positive and this negative, and therefore the this would be positive 9.8. Okay, so you have to be very careful about your signs. Okay, more so in a situation like this. This situation has two examples, or excuse me, just one example. I'm sorry. The one thing you want to know about this: sometimes we toss an object into the air. We toss an object into the air. If an object is going upwards into the air, that is still equal to free fall. That is still equal to free fall, okay? An object going up or an object going down are both in free fall, okay? Because this object will stop eventually and then go back down. And so very often with questions like this, there's a whole variety of things we can ask for questions like this. But the one thing I just want to point out is that when this coin, for example, is going to go up, at the very top of its arc right here, at the very top of its ascent, the velocity is equal to 0 meters per second. So once again, maybe you're going to use this equation right here. V final squared equals v squared plus 2a delta x. This is one of our kinematic equations. Well, if we just look at the first half, of it going from the finger to the top here, if we look at that first half, the initial velocity is 5 meters per second. So that would be this one right here, 5 meters per second, and the final velocity is going to be 0. And if that's 0, this equation gets a whole lot easier to solve, and we would just plug in g here for acceleration. And once again, because in this person says it as negative, we would call this negative 9.8. Okay, so that's one tip. Always call the top of the path. The top of the path is always going to be 0 meters per second. Things have to stop before they come back down again. And just as a general rule of thumb, if you do have a problem where it does go up and then come back down, I recommend splitting it into two halves. The first half and the second half. The first half being the object going from starting off at a speed and then stopping. That would be the first half. And the second half being it stopped to going back down wherever it's going. So right here you would have an initial speed. Here you would have a final speed. Your final speed is equal to 0. Here your initial speed would be equal to 0. And then down here your final speed would be equal to, something. So those are just some tips with free fall acceleration. Free fall, once again, is an object falling at constant acceleration due to gravity in a frictionless environment.